X-intercept form, y equals a times x minus r times x minus s. Consider the quadratic function f of x and a real number s. If f of s equals 0, the following statements are true. S is a 0 or root of the function f of x equals s is a solution of the equation f of x equals 0, and s comma 0 is an x-intercept of the graph of f of x. Note, a 0 or root is a number that corresponds to the x-coordinate of an x-intercept. A 0 is not a point in the plane. Practice. Find the zeros of the quadratic function. To find the zeros, we just take this and set it equal to 0. So in this case, we can factor it. We have x and x. There's going to be one plus sign and one minus sign since this is negative. And 9 and 1 are going to work. Because this is negative 8, we know the 9 will be negative, and 1 here, and that is good. All right, so our zeros are going to be when x equals negative 1, because negative 1 plus 1 would be 0, or 9, because 9 minus 9 would be 0. So our zeros here are negative 1 and 9. Here, set this equal to 0, so we have x minus 3 squared equals 16. Take the square root of both sides, and we get x minus 3 equals plus or minus 4 once we take the square root of both sides. So that would be x equals 3 plus 4 or x equals 3 minus 4. So these zeros are going to be 7 or negative 1. And there you have it. All right, so we're going to set this equal to 0. That gives us x squared equals 21, or x equals positive or negative square root of 21. Since this can't be simplified further, these are the two zeros. Down here, we can set this equal to 0. So x plus 5 squared equals 13. Take the square root of both sides, and we get x plus 5 equals plus or minus the square root of 13. So x equals negative 5 plus or minus the square root of 13. And there we go. The graph of g is shown. Below are formulas in standard form and in x-intercept form. To change forms from standard to x-intercept requires that standard form can be factored. Standard form would be x squared plus x minus 2. The zeros are at negative 2 and 1. So then we can plug that into x-intercept form where we have x plus 2 and x minus 1. And then we can use FOIL, multiply it out, confirm that we end up with this to confirm that this is correct. And you can see that once we do FOIL, it checks out. We have x squared plus x minus 2, which is the same as we had up here. So this is a correct factored form. Write an equivalent function in x-intercept form. All right, so we just need to factor these. So here we have 2 times, so if we took out 2x from these, we would get x plus 2. We can also rewrite this a bit, so it's going to be x minus 0 times x plus 2. So this is our factored form of this. We put that minus 0 in there. We don't have to, but we do it just so that it looks like this. All right, next one. We can just factor that. So x and x, this is positive, that's negative, so we're going to have 2 negative signs. And 4 and 2 are going to add up great, so this is our x-intercept form. Moving on, we can first take the negative sign out. So we have x squared minus x minus 12. I'll erase that. All right, so now we factor this. So we have x and x. This is negative, and that's negative, so we're going to have a plus and a minus sign here. And 3 and 4 will work, and since this is negative, the 4 will be negative, the 3 will be positive. All right, there we have it. And finally, this last one, first let's divide the whole thing by 2. 12x plus 20. All right, and then we're going to factor this. So 2 times x and x. These are both positive, so these will both be plus signs. And 10 and 2 will work. And there we go. Looks good. The graph of h is shown. A rule is given in standard form. What is a rule for h in x-intercept form? Alright, well here's standard form, and we're actually given the zeros, which makes our job really easy. So h of x in x-intercept form is just going to be x plus 1 times x minus 3. So remember, you're just going to be putting negative 1 in here. Negative 1 plus 1 equals 0, or put 3 in here, we get 3 minus 3 is 0. So there we have it.